Condoms are one of the most important public health products ever manufactured. Thin, flexible barriers designed to prevent pregnancy and reduce the transmission of sexually transmitted infections. Yet, behind every rolled latex sheath is a highly technical industrial process involving chemistry, precision dipping, curing ovens, automated testing, electronic inspection, and ultra-clean packaging environments. What appears to be a simple disposable item is actually produced under some of the strictest quality and safety standards in the consumer goods industry. And today on the How Factory, we're going inside modern condom manufacturing plants to see exactly how condoms are made, from liquid latex to finished protection trusted by millions of people worldwide. The process begins with the raw material, natural latex. Latex is harvested from rubber trees primarily grown in tropical regions. Farmers tap the bark of mature trees, allowing a milky sap to flow into collection cups. This raw latex is filtered and stabilized at collection centers before being transported to condom factories. By the time it arrives at the plant, latex is a liquid suspension of rubber particles in water. Each batch is tested for purity, viscosity, elasticity, and protein content. Consistency is critical because even small variations can affect strength and thickness in the final product. Inside the factory, latex is first compounded. This means chemical additives are blended into the liquid latex to improve performance. These additives include curing agents, stabilizers, accelerators, and sometimes colorants or lubricity enhancers. Large stainless steel mixing tanks gently agitate the latex while maintaining precise temperature and pH levels. The formulation is carefully controlled. Too much accelerator can weaken the latex, while too little can prevent proper curing. Once mixed, the latex is filtered again to remove microscopic impurities that could cause defects. Next comes one of the most recognizable stages: dipping. Condoms are formed using ceramic or glass molds called formers, shaped exactly like the final product. Thousands of these formers are mounted on long conveyor chains that move continuously through the production line. Before dipping, the formers are thoroughly cleaned using chemical baths, hot water, and steam to remove any residue. Cleanliness here is critical. Any dust or oil can cause holes or weak spots. The cleaned formers are first dipped into a coagulant solution, usually made of calcium nitrate. This prepares the surface so latex will adhere evenly. Immediately after, the formers are dipped into the liquid latex. The speed of immersion, withdrawal rate, and dwell time determine the thickness of the condom. For thinner condoms, the dip is brief. For thicker designs, the former may be dipped multiple times. Gravity and controlled rotation help distribute the latex evenly along the former. After dipping, the latex-coated formers pass through drying and curing ovens. Heat causes the latex particles to bond together in a process called vulcanization, transforming the liquid coating into elastic rubber. Temperature and exposure time are tightly regulated to achieve the correct balance of strength and flexibility. If curing is incomplete, condoms may tear easily. If overcured, they become brittle. Sensors continuously monitor oven conditions to maintain consistency across tens of thousands of units moving through the line. Once cured, the condoms are no longer liquid, but they're still attached to the formers. The next step is bead rolling. Automated brushes or rollers gently roll the open end of each condom into the familiar rim. This rolled bead increases strength and makes the condom easier to unroll during use. The bead must be uniform. Uneven rolling can affect fit and reliability. After bead formation, the condoms are leached. Leaching involves washing the condoms in hot water multiple times to remove residual chemicals and excess proteins from the latex. This step improves comfort and reduces the risk of irritation or allergic reactions. Modern factories use long water baths with precise temperature control, sometimes followed by additional leaching after removal from the formers. Once leaching is complete, the condoms are stripped from the formers. Air jets or mechanical fingers gently remove each condom and transfer it to the next stage. At this point, the condoms are inside out compared to how they will be packaged. They are inverted later during finishing. The stripped condoms are dried again and sent to inspection and testing. Testing is one of the most critical parts of condom manufacturing. Every single condom must be tested for holes, not just sampled. The most common method is electronic testing. Condoms are placed over metal probes and rolled through an electric field. Because latex is non-conductive, any tiny hole allows current to pass through, triggering an automatic rejection. This test can detect holes far smaller than the human eye can see. Condoms that fail are immediately discarded. In addition to electronic testing, samples from every batch undergo air inflation tests. Condoms are filled with air until they expand many times their normal size, measuring burst pressure and volume. This ensures strength and elasticity far beyond real-world conditions. Water leak tests are also performed, where condoms are filled with water and checked for seepage. These tests are mandated by international standards and regulatory bodies. After passing testing, condoms move to lubrication and finishing. Most condoms receive a thin coating of medical-grade silicone lubricant to improve comfort and reduce friction. The amount of lubricant is precisely measured. Too much can make handling difficult, too little reduces effectiveness. Some condoms also receive spermicidal coatings or specialty formulations, depending on the product. Next comes drying and inversion. Condoms are dried to remove excess moisture, then inverted so they're oriented correctly for use. This process is fully automated, using air pressure and rotating drums to flip each condom without damage. Once inverted, the condoms are ready for packaging. Packaging takes place in clean room environments to prevent contamination. Individual condoms are fed into high-speed packaging machines that fold them into compact shapes and seal them inside foil wrappers. These wrappers are made from laminated materials that block light, air, and moisture, preserving the latex over its shelf life. Heat-sealing jaws close each packet, printing batch numbers and expiration dates at the same time. Each seal is inspected for integrity. Wrapped condoms then move to secondary packaging lines. Individual packets are counted and grouped into retail boxes using automated systems. Boxes are folded, filled, and glued at high speed. Instruction leaflets are inserted where required. Vision systems confirm correct counts and labeling. Finished boxes are packed into cartons, palletized, and prepared for distribution. Behind the scenes, quality control and documentation never stop. Condom factories operate under strict international standards such as ISO and WHO guidelines. Every batch is fully traceable, from raw latex source to final shipment. Laboratories inside the factory continuously test raw materials, in-process samples, and finished products for tensile strength, elasticity, aging resistance, and chemical safety. Retention samples are stored for years in case future analysis is needed. Environmental control is also critical. Latex is sensitive to heat, light, and ozone. Factories maintain controlled air quality and temperature to prevent degradation. Water used in leaching is filtered and recycled where possible. Waste latex is collected and processed to reduce environmental impact. Many modern plants are investing in sustainability programs to reduce water and energy consumption. What makes condom manufacturing remarkable is the combination of extreme thinness and extreme reliability. A condom may be only fractions of a millimeter thick, yet it must withstand stretching, friction, and pressure without failing. Achieving that level of consistency across millions of units requires precision chemistry, automated inspection, and relentless quality control. There is no margin for error. From liquid latex flowing through stainless steel tanks to high-speed dipping lines, curing ovens, electronic testers, and sterile packaging rooms, the entire process is engineered to produce a product people can trust without hesitation. Every condom represents dozens of controlled steps and multiple layers of testing, all completed in minutes on a continuous production line. And that is exactly how condoms are mixed, dipped, cured, rolled, washed, tested, lubricated, sealed, and packaged. A highly advanced industrial process hidden behind one of the most essential health protection products in the modern world. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, systems, and factories behind everyday products.